Chapter 2, Video 5. We're going to talk about the cardiac cells a little more in depth. There's several things that you need to know, several terms that you need to know and recognize. Automaticity is the ability to create an impulse without outside stimulation. And conductivity is the ability to conduct an impulse to the neighboring cells, so that sends the impulses out to the neighboring cells. And excitability is the ability to depolarize. Contractibility is the ability to contract. Automaticity, conductivity, excitability, and electrical characteristics. Remember, contractility is mechanical. That's very important. You may see that again. The sinus node is also the pacemaker of the heart, and that was discussed in the previous video. Other cardiac cells can become the pacemaker of the heart if that sinus node fails. If the original sinus node fails, then other cells can pick up and take over and act as the pacemaker of the heart. So what we mean by that, like the sinus node is the normal pacemaker, and you have a heart rate of 60 to 100 beats per minute. The AV junction is the backup pacemaker. The AV junction produces a rate of 40 to 60 beats per minute, and then we have a third pacemaker in the event the AV junction fails. So if you lose your sinus node and then you lose your AV junction, then we have a third one, which is the ventricle. It's the lower pacemaker. It's the backup, but it has an inherent rate of 20 to 40 beats per minute. The ventricle, acting as a pacemaker, is the slowest pacemaker of the heart. So each one gets slower. So the sinus node is the normal. It's the normal pacemaker of the heart. It's the beginning of the conduction system, and it produces a rate of 60 to 100 beats per minute. And then we have the AV junction, which is the backup, and it slows down more. And then we have the ventricle, which is another backup, and it slows down to even a lower rate than that. So please know these. If the sinus node and the atrial fail, what will be absent on the EKG strip? This is just an example question. So if the sinus node fails, what is going to be absent on that EKG strip if the sinus node and the AV junction fail, if both of these fail? The answer to that question would be the P wave, because remember, the sinus node is in the atrium. The sinus node is the start of that pace, the start of the heart rhythm. It's the start of the electrical cycle, and it produces that, it fires, and it paints that P wave. It makes the atria contract. So here's an example question of something you may see on the test. If the sinus node and the AV node fail, what do you expect the heart rate to be? So if you lose the sinus node and you lose the AV junction, what do you anticipate that heart rate will be? I would say 20 to 40, because you've lost the sinus node, you've lost the AV junction, so the ventricles are going to be active. So it's not going to be cut and dry. You're going to have to think about what's happening. So if you're told that you have lost the sinus node is not working, what do you expect the heart rate to be? Or 40 to 60, because we know that the AV junction is the backup pacemaker. It will go into effect and work before the ventricles will. We're going to talk about inherent escape rates of the pacemaker. The fastest pacemaker at any given moment is the one in control, okay? Lower pacemakers serve as backup, and they are inhibited from firing as long as the other pacemaker is working. So as long as the sinus node is working, the AV node and the ventricles, they're stopped. The brakes are put on. They're not going to fire because they're not allowed to fire because the sinus node is still working. But let's talk about an escape beat. An example of an escape beat is a beat that appears on a rhythm strip after a long pause and causes a slower rhythm than normal, okay? So it messes with your rate, but an escape beat is a life-saving beat, okay? So if your heart skips that beat and that SA node fails to work, and then your AV decides it's going to pick up or whatever, you're going to have that escape beat. You're going to have that pause where the heart stopped, and then one of the other pacemakers decided it was going to go to work and produce that escape beat. All right. I'm going to scroll on down. An escape beat is a predominant pacemaker slows dramatically or fails. So this happens. We have an escape beat if a predominant pacemaker fails or slows. What happens is the lower pacemaker takes over at a slower rate. And an escape beat is any beat that comes in after a pause that's longer than the normal heartbeat to heartbeat cycle. Escape beats are lifesavers. An escape rhythm is a series of escape beats. So if you look, what we mean by this is we have our QRST. Okay, we don't have a P. QRST, and then we get nothing, and then all of a sudden our ventricles fire because they're like, okay, we got to go to work. Something's not right with sinus node and AV node, so we're going to work. So this ventricle fires and produces that life-saving beat. So that's what you're seeing there. Now we're going to talk about usurpation. Usurpation. You need to know this definition. You need to plan it to memory. You need to know the terminology because you will see this again. Usurpation is irritability. It's basically taking control away from. So it comes in and it usurps the normal rhythm. Your heart's irritated, wherever it may be, in the AV node or in the ventricle. It gets irritated and it comes in and it takes over. It says, I'm not putting the brakes on today. I'm going to take over and I'm going to work. Lower pacemakers takes control and fires at an accelerated rate, stealing control from the predominant pacemaker. That is what usurpation means. It results in a faster rhythm than before, and it starts when a beat comes in earlier than expected. So you can see here we're very irritated. We have a normal PQRST. We have a little bit of pause, PQRST, and then this bad boy fires up and says, "Oh, I'm taking control today." All right, now we're going to talk about conduction variations. The proper function of the conduction system results in a heart rhythm. The pattern of successive depolarizations originates in the sinus node. Abnormalities can produce arrhythmias. Abnormal heart rhythms can prove harmful or fatal if not treated. A heart rhythm equals the proper function of the conduction system, but an arrhythmia, ARRHYTHMIAS, abnormalities of the conduction produce these, so it's an abnormal heart rhythm. An example of an arrhythmia would be bradycardia, which is a slow heartbeat. All right, we're going to take a peek at the EKG paper. This is very important, guys. There's a table 2-3. I need you to know that table, and I'm going to pull over here and go over what the EKG paper represents with you. The EKG paper represents left to right. We're looking at time, okay? We're looking at time, so we count the blocks. One little small block that you see here is 0.04 seconds. One big block, so we can go over and we can see the highlighted big block. One big block equals 0.20 seconds. And then 5 big blocks, 1, 2, 3, 4, 5, equals 1 second. It's very important that you know, moving from left to right on an EKG paper, EKG graph paper, that you are looking at time. And it's very important to know what each of these mean. You need to plant this chart to your memory. You will see it again when you're diagnosing strips, and you will use it. So please plant that to your memory. We're looking at, we use this type of graph paper when we're getting an EKG printout. So with the 12-lead EKG printout of the heart's electrical activity, it's viewed from 12 different angles. It's done on that special paper that I was just showing you, and it uses a digital recorder that prints simultaneous views of 3 leads at a time in sequence until 12 leads are recorded. So I want you to review and understand the EKG. And I think that'll do it for this video. I will put up another one at a later time.